Hello Spider Peeps. So in a previous video I got pico-mac working on this Temu RP2040-Zero. Obviously changed a few things, put a PCB socket on it, I put a LED on it because I just needed a standard GPIO driven LED to check the heartbeat to see whether it was working. Obviously I need to put power in it. So I was pretty happy with this, but I am not happy with this mess. So because I've done a load of PCBs before, guess what this video is going to be about? Yeah, I'm going to convert this into a PCB so that you can run little Macs on a Pico RP2040 or this little Pico RP2040 and get these wires tidied up a little bit. All right, so let's go to easyeda and let's see what we can do to create one. Okay, so I've just pulled in some of these objects by searching in the library. For instance, if I go to the library and search for RP2040-Zero, then if I click on that, this looks exactly the same. See, there's a little picture of it. The pinout looks the same, and this is the circuit diagram. So I was able to just place that on the board. Then I've added a 5 volts and a ground rail there and connected those to it. I've loaded in some surface mount resistors because hopefully I'm going to try and get some of the bits on the board built for me. This is a DC barrel plug. I'm not sure about that. I'm not sure whether I'm going to use that, or actually let's have a look at using a micro USB instead. Let's see whether I can just find one, see what it's called. Oh, that's the sort of thing, isn't it? Yeah. That's exactly what I need. Let's just place one of those on as well. Yeah, that should be all right. So there's my micro USB, and we've got ground and V-bus. That's all I need really to get the voltage in. Normally on this I put the connectors on like so, but I think to make it a little bit simpler on this occasion I'm going to use these little ports and it will bring a cleaner diagram together, I think. Now here's my two 68 ohm resistors for the sync, and here is the 100 ohm resistor for the video output signal. Now to explain what I mean by vertical and horizontal syncs, you best to go and look at the video that I did previously on this, and you can see what all of these mean if you're interested. So I've got a barrel jack and I've got a USB for the power in. This is the Pico, this is the VGA out. Now the other thing I want to put in is an LED, driving this from 3 volts I think. So let's just type in resistor for blue LED, 5 volts. Try that. So which resistor to use for blue LED? I could work this out, but it's easier to Google it. 100 ohms. Okay, that's cool. Now I'm already using 100 ohms, aren't I? Yes, I'm already got 100 ohms. So let's just copy that and paste it. Let's wire that up first. So on my Pico, so the resistor goes to pin 28. So let's take this and go and change that net port 3, change that to GP28. All right, and if I connect that to there, that's GP28. I think I have to flip it round. Does that flip it? Can I just move that the other side? Yeah, GP28. And then connect that up. All right, I think that should have done it. I'm going to zoom in a little bit here. Yeah, that looks okay. So that GP28. And then down here, copy and paste that. The LED goes to ground, so let's put a ground there, and then I've got to find a surface mount LED for it as well. Let's copy that and put that down there. So GP28 then goes to the resistor, and then that goes to an LED and ground. So let's find an LED. So I need to flip that around because that bar goes to ground. So let's wire that one up. So it'll just be a case of going from there to there, then from there to there, and then from there to ground. The next part is going to be, let's call this one video. We're going to put video to GP9, if you recall. So I think this needs to be rotated a little bit. So let's do it that way. Move it to there. So let's move these move this little assembly down a little bit. Whoops. And now video can go to pin 9. This one's going to be H-sync, and this one is going to be V-sync. And again, let's flip that so it's pointing up, and flip that so it's pointing up as well, and move these down. So V-sync goes to the first one, so V-sync comes over there, that'll go to 11, and then, not to make the error I did before, we will move, whoops, so no, that's got to go 9, 10, and then 12. Mustn't get these mixed up. So yeah, I'm doing GPI 9, 10, and 11 is the clock that we don't use, and 12 is the other one. So before I do that, let's just copy these, because I'll need to use these elsewhere. Put them back up there, and let's just wire these up. So that goes to there, that one goes to there, and that one goes to there. Lovely. So these have got to go through those resistors to the various parts of this, haven't they? So let's move the resistors that I've not already used up there. Now the first one, the 100, goes to 1, 2, and 3. So let's flip him round and put him there. Then I can just wire this one up. So there to there, there to there, and there to there. Lovely. 1, 2, and 3. Take the video, and I do need to flip this, don't I? So let's flip it that way. Put the video there. Move you out the way for the moment, and wire that one up. That looks good. Just move this connector out the way for the moment. All right, let's do the grounds while I'm here. So I'll put another ground in. And what were the grounds? So 5 went to ground. Let's put that up there. So I'll just wire that 5 into there, and there was some more, weren't there? So I've got to do the other grounds, which were pins 5 to 8. Where's 6? So 6 comes down here to ground. 6, 5, 6. Then 7 goes to it, and 8 goes to it. So that's sorted the other grounds out. And then the other interesting ones were 13 and 14, weren't they? So we've got 13 and 14 there. So 13 had to go to the horizontal sink, and 14 the other. So let's mirror those, and move them down there. So let's grab this again, move all those out the way now, and move these across a little bit. Okay, so resistor 2 goes there, and resistor 3 goes underneath. 13 goes to H-sync, so I should have enough room for this. Well, I've got to move it around a little bit. Woo, woo. 13, and then 14 goes to that, and let's not forget to connect it to the buses. That's virtually there. So that's the VGA connected. We've got the video signal in through that 100. We've got the V-sync going in and the H-sync going into those two, and then we've got all them grounded up. So that's all we need on the VGA. We've got this 5 plus 5 volts. We've got that coming in. So we need to make sure that everything on this is connected to that plus 5 volts. So let's put another 5 volts there, and then we can connect there to there. So that's 5 volts to the pin of that barrel connector if we choose to use it, and then we've also going to connect that 5 volts to the V bus of the micro USB connector. Finally, there's just the ground of that, and to save all these wires crossing, I'm just going to add a couple more grounds. Let's add a ground there, and let's add a ground there, and you know what we're going to do with that. So let's just wire from there to there, and there to... Okay, so I think that's it. I'll just come out a little bit again. It's hard to show all this on the screen now, I think. It's not too bad. No, it's not too bad, is it? Look at that. Yeah. So I've got the Raspberry Pi. We've got this little GP28 is our little addition, the little light that we're putting on board. the flashing light. I could do a power light as well, couldn't I? Might be exciting, but no, let's leave that. So we've got a flashing light telltale. This bit is the video signal coming in, which goes to all three of them. We've got the ground that goes to the video RGB grounds, and that ground. Got the horizontal and vertical sync. We've got the USB that's got both power to it, and that's got both power to it, and the chip's got both power to it. Okay, so that is the circuit diagram. Now, if I hadn't have used these little things, I probably could have made this so I wired it all up. But I think this is a little bit more simple way to do it. And I've not done this before, so using these little bus things, but hopefully I've done it right. So let's save that. Save successfully. Now the magic. Let's go to design and say convert schematic to PCB. So there are some unfinished nets. Do you want to check the nets first? I don't know what that means. Well, I suppose it's because these aren't connected, but that doesn't matter. So I'm just going to say no, keep going. All right, so we've got to work out how big the board is. I'm just going to leave the board as big as this at the moment, and let's just go with that. I do like to do round rectangular though, and well, let's just do it like that and see what happens. Yeah, so there's a nice looking board, probably a bit too big. I want to make this as small as I can really. And here are the connectors. So really this whole thing needs to be based around that. So if I put that pico on the end, or if I do put that pico on the end, but this, I want this to be, well, we've got to put that, and we've got to put the two powers on, haven't we? Maybe that's right there. Let's see what else we've got to put on there. We've got the LEDs. This is the power. This is the power in USB. Okay, this has got to be further out. So we could get into that from the side if we put that there, and if we put that there, this big thing has got to be the width of everything. Everything else needs to go around that. And then this USB, if we rotated that way, that's about the right width of the board, isn't it? I can now move that to there. That's the Mac on there. So this board can be a lot smaller than this, but we've got our different resistors and we've got the LED. So let's put the telltale LED. Let's put the telltale LED up. These could go anywhere, couldn't they? So can I rotate these a little bit? Yeah, so if I put those there, I'll put them that side. And then put the LED up by the power bit. Yeah, I think that's probably all we need. And then we can make the board a lot smaller now. So let's go back to the board outline, set board outline. Let's just do it rectangular to start with to see how big I can get it. So forget about the start and the end, I can leave that. So the width and the height 30, and the height is 30. Let's see that. Width 30 and the height 30, apply that. Okay, so the width is about right on that, but the height's got to be more. Board outline, and the height not to be too much, so let's set the height to 50. And I think that's right, maybe 45. Hey, that's about right. Yeah, I can squeeze that up, can I? No, let's do 46. And let's put a curve on it on the edges, which is always nice. Round rectangular, and let's do a small radius. Let's do a radius of 2 on there, see how that works. That's it, just nicely eased over. So now I can adjust these in here. Let's if I save that as we stand and just look at it in 3D and just see whether it looks right. So yeah, little USB comes, there's plenty of space on there, and then when we put that in there, might be a little bit tight soldering that, so I'll move that up a little bit. I'll buy these separately, I won't get them to build it like the same way as that one, but the rest of it looks okay. Alright, so my final part of this would be making it look pretty, but one thing that I like to do is to take the copper area, there we go. Okay, select it to ground, and then I just draw a square around this, and what that does is make sure that there's like a ground plane on it of copper. And I always mess this little bit up at the end, but that doesn't matter. So see, that's now all one colour. And I was going to move this up a little bit, wasn't I? So let's move that up a little bit. So I go to root and auto root. And normally you can just run it, and then hopefully we'll have all the tracks on there. And all of them, I normally just check to see none have failed. So that's all we do. So all I've got to do is prettify it up. I'll put my Spidermaf logo on it. Let's just have a look at that in 3D as well. Let's just save it. And yeah, it's looking nice. Oh, this is a bit disturbing. All right, so... Oh, no, that's fine. Oh, I see what they've done. So they've made it so that we can solder the board directly onto it. I think I'm going to leave it like that. I think that's really cool. I probably need to put it a bit towards the top of the board so it hasn't got that little bit on there. So yeah, the one that I chose has got a cutout for that. I think I'm going to leave that. I like that. So let's turn that off. And let's just jiggle that forward. I'll just push it up twice. I need to auto root again because I've moved it. And then pick the 3D. Yeah, so we can solder directly onto that. So that's going to be exciting. That means I don't have to use header pins, but can still get to the back. So I actually like what it's suggested there. Lovely. All right, so, and then the next time you'll see me, hopefully I will have these boards in my possession. And that's where I've got to end this video this week. I was really hoping to have these boards to show you, but the delivery of these, I've been let down this time. Last time I ordered something, it left Hong Kong, and 3 days later I had the boards here with me. On this occasion though, it left on Monday and they still haven't arrived, so the tracking's there. It's at a place called the London Borough of Hillingdon. That's just Heathrow Airport. So it has arrived in the country, but it got too late for me to get it to the end of the video. The thing about that though is if you subscribe to this video, you'll get to see the boards when they arrive, and I can solder them together and we'll play about with them and we'll see whether it's worked then. So this video has just ended up being about designing a circuit board today. Hopefully I'll have something to show you next time. Bye.